So in this lesson, we're going to talk about the very basics of graphing a rational function. So we're going to have more in-depth conversations about graphing rational functions later, but for now I just wanted to get down the basics. So the very first piece of talking about the graph of a rational function is talking about its asymptotes. So for now, we've talked about vertical asymptotes, which occur when the denominator is 0, and horizontal asymptotes, which constitute the eventual behavior of a function. And if your eventual behavior is that the function approaches some constant, you've got yourself a horizontal asymptote. The next thing we'll talk about is intercepts. So, of course, you have x-intercepts and you have y-intercepts. And as I talked about in my lesson on vertical asymptotes, for the x-intercepts, we're really just looking to see where the numerator is going to be 0. For the y-intercepts, I'm hoping you all are still familiar with those from other contexts where we talked about them. This is where you just let x be 0 and see what happens. And then the last piece before we go to graph is we'll make a sign chart of the function. So again, this is making a sign chart of a rational expression, something that we should be fairly comfortable with by now. And we've also had a little bit of experience in our polynomial unit taking a sign chart and extrapolating what the graph looks like from there. Now, the good news is for this lesson, I picked the two functions that we've been looking at in over the course of the last few lessons. So we already have a lot of the information. So for our first example here, we already know that the function f of x equals 1 over x minus 2. The vertical asymptote, which I'm abbreviating v dot a, is the line x equals 2. And the horizontal asymptote, which you'll remember we constructed a table of values for, is the line y equals 0. Now for the intercepts. Well, remember, x-intercepts are where the numerator would be equal to 0. The numerator here is 1. It's a constant. It's never going to be equal to 0. So there are no x-intercepts. And then for the y-intercept, well, let's see. If we plug 0 in for x, we get negative 1/2. And so we see that we do in fact have a y-intercept at the point 0, negative 1/2. Last, before the graph, let's look at the sign chart. So again, I'm very much hoping that you remember how we do sign charts. So the only critical number here is going to come from the denominator, and that's 2. And let's test a point. Okay, so we can test 0. Useful to test 0 because we've already plugged it in. So I already know that at 0 this expression is negative. So try as much as you can to kind of reuse information that you found in previous steps. So that means that we are negative to the left of 2, and since there are no non-negative factors, we are positive to the right of 2. So now let's put all of this together. I always start, when graphing a rational function, I always start by really carefully labeling my asymptotes. I tend to do it in red. So I'm going to say this is the vertical line, x equals 2. Okay, now my horizontal asymptote is the line y equals to 0, which is just the x-axis. So it's not really possible to label it clearly in a way that's super visible, but I'm going to do it anyway, and I'm going to say that I've got a horizontal asymptote there. Notice, this is important, I saw that I have no x-intercepts, which means that my graph does not cross its horizontal asymptote. It's possible to cross the horizontal asymptote, but this graph does not. Next, let's plot the intercepts that we do have. So we have the y-intercept 0, -1/2, which is about there. And last but not least, the sign chart. So the sign chart tells me that I am negative to the left of 2. So that means that the graph is below the x-axis everywhere to the left of 2. But I also know that I have a vertical asymptote, which means that I have this kind of plunging behavior. And I have a horizontal asymptote, which means that I approach 0 without ever actually getting there. So that's what I have happening to the left of 2. To the right of 2, I'm positive everywhere. If you want, if it would make you more kind of comfortable with the precision of your graph, you could take a value of x to the right of 2 and plug it in. Like, for example, when x is 3, 1 over 3 minus 2 is 1. So you know it passes through this point. But you don't have to, because remember, for our purposes, graphs are very largely sketches. As long as the general shape is there, the minute particulars aren't super important. Again, we have an asymptote at x equals 2. So again, we have this sort of surging behavior where we go really, really high. And we have a horizontal asymptote at 0. So we go closer and closer to the x-axis without ever crossing it like so. So again, when graphing a rational function, we are going to stick to these 3 tenets: asymptotes, intercepts, sign chart. What we are not doing in this video, that we will do in future videos, is adding to the intercept step to consider the question, does this function cross its horizontal asymptote? For now, you're just going to sort of take my word for it. It's going to be an act of faith. But in future conversations, we'll actually flesh that out and look at sort of examples where that gets a little bit more interesting. For this function, the other example, okay? So let me actually move this up a little bit so I have all the room that I need. I'm going to move this up here. Okay? So, here. There. I'll move it like so. Okay, so asymptotes, I already know, right? We talked about them in previous lessons. So we have a vertical asymptote where the denominator is equal to 0. 2x plus 5 is equal to 0 when x is -5/2. And the horizontal asymptote, that we talked about in the lesson right before this one, it'll be the line y equals 3/2 or y equals 1.5. Now intercepts. So we did that in green. So let's get that same color going. Intercepts. So remember, intercepts are all about, for the x-intercept, where is the numerator going to be 0? So we take 3x minus 2, we set it to 0. Let's actually work that out. We can add 2 to both sides, divide by 3, so we'll get that x is equal to 2/3. So this function actually, its graph crosses the x-axis at the point 2/3, 0. And then for the y-intercept, same thing. We plug 0 in for x. So you'll have 0 minus 2 over 0 plus 5, which is -2/5. A little bit, not quite -1/2, right? So there we are. And then lastly, our sign chart. So remember, critical numbers come from both the numerator and the denominator. So what you're going to notice, speaking of recycling work, that you're going to have one critical number that comes from your vertical asymptote and another one that comes from your x-intercept. So your critical numbers are -5/2 and 2/3. As always, don't worry too much about scale. It's all about position. Since -5/2 is negative, it's to the left of the 2/3. Remember, recycle. So test 0. You already know, because of your work here, where you found the y-intercept, that this function is negative at 0. And then you also know that there are no non-negative factors, so it'll be positive on either side, like so. All right, same thing, graph time. So x-axis, y-axis. Okay, so we have a vertical asymptote when x is -5/2. So that's -2.5. So I'm going to dot it in. I'm sure you guys can do a nicer job if you use a ruler, which I did not. And then you have a horizontal asymptote where y is 3/2. So that's this line here. So what I'm going to ask you to take on faith for now, I'm not going to go into exactly why this happens. This function also does not cross its horizontal asymptote. So for this lesson, I'm keeping it simple, functions that don't cross their horizontal asymptotes. But now let's move on to intercepts. So I have an x-intercept at 2/3, 0. So that's not quite at 1. And a y-intercept at 0, -2/5. So that's not quite at -1/2. Okay? And finally, sign chart. You can go left to right on your sign chart. I like to pick one. So if I go left to right, that means I'm starting with this section first. And I'm seeing that the function is positive everywhere to the left of -5/2. So what that tells me is the graph is entirely above the x-axis, true, but also I have a horizontal asymptote that I don't cross, which means I have to hover entirely above it, and I have this vertical asymptote, which means I have that kind of surging behavior. So the asymptotes and the sign chart together dictate the shape of my graph. Again, if you want to, you can plug a value in for x and actually plot a specific point. But as long as you've got the basic shape, it's not terribly important to do that. Exactly the same sort of thing happening on the other side. Between -5/2 and 2/3, we are negative, which means our graph is below the x-axis, but we have a vertical asymptote here, which means we're going to have this kind of surging behavior downwards. So it looks something like this. And then from 2/3 onwards, we have to be above the x-axis, but we've got a horizontal asymptote that we know for now because I told you that we don't cross it. So you have this shape where you're approaching y equals 3/2 without ever crossing it. So there is our shape. Like I said, we will be talking more about kind of graphing more intricate rational functions in future, but the structure is going to remain the same. Analyze the asymptote situation, analyze the intercept situation, build the sign chart, and then combine all three of those things to look at the graph. This will be the third of 4 or 5 lessons on rational functions. And we'll stop here for now.